Problem 3 requires us to draw a chair conformation for the molecule that's given, and specifically we're looking for the most stable chair conformation. So let's start by drawing our chair. And I'm going to draw in all of our substituents. Now, as we try to convert from our drawing over to our chair conformation, we need to figure out one of two things. In general, we find that we set up our chair conformation by either trying to get as many substituents into equatorial positions, or if there's a very large substituent such as a T-butyl, we try to make sure that that T-butyl is in an equatorial position. Now, this molecule does have a T-butyl group, as we can see here, so that's going to be the basis for the rest of our chair conformation. So we can see that that T-butyl group is pointing down, so I'm going to put that T-butyl in an equatorial down position such as this one. Now, what I'm also going to do is I'm going to label the carbons in our ring here. Now, don't get these numbers confused with nomenclature, because the only purpose of these numbers is it's going to allow us to better map from one drawing to the other. If we were doing nomenclature for this question, these would not be the correct numbers. So I'm not concerned with nomenclature right now, just that we map our substituents correctly from one drawing to the other. Now, on that first carbon where we put the T-butyl group, notice the other substituent, the one pointing up, is a hydrogen. So I can't just leave the axial position blank there, because right now it looks like it's a methyl group. So I either need to put in a hydrogen there, like that, or erase it completely. Now, as we continue around the ring, on the second carbon we have a methyl pointing up and a bromine pointing down. Our third carbon has an ethyl pointing up and a methyl pointing down. Carbon 4 has a fluorine pointing up and a methyl pointing down. Carbon 5 has an ethyl pointing down and pointing up. Nothing's drawn in, so we know it's just a hydrogen. Carbon 6 has an ethyl up and a hydrogen down. So that is what our chair conformation for this molecule will look like.